Hi there, this is Math 7, Unit 4, Lesson 6. We're talking today about increasing and decreasing, and we're going to use percentages to describe increases and decreases in various amounts. Okay, so you began today, first of all, with an activity that's called Improving Their Game. And it said here are three scores, scores from three different sports teams for their last two games. Now you can see a football team had 22 points in the first game and then went up to 30 in the second. A basketball team had 100 points in the first game and then 108 in the second. And a baseball team had 4 and then went to 12 in the second. So the first question asks, what do you notice about the team scores and what do you wonder? And so hopefully in your class you have a discussion today about things you notice and things you wonder taking place between game 1 and game 2. A couple things you might notice is that, gosh, everybody seems to certainly improve between game 1 and game 2, don't they? From 22 to 30, there's an increase there. In terms of points, we could say, well, this team definitely improved by 8 points to go from 20 to 30. This one also improved by 8 points, as did this one. They all improved by 8 points. The difference, though, could be something along the lines of, well, while they all improved by 8, there's a big difference between going from 100 to 108 and going from 4 to 12 in terms of perhaps the overall percent of growth that they're making. For example, the difference between 4 and 12 is multiplying by 3 is what it takes to go from 4 to 12. This team improved its score by 3 times, right? The first game they had 4 and they tripled their score in the second game. These other guys did not triple their score. What would happen if the basketball team tripled its score? We would expect this to be 100 times what? 100 times 3. So we would expect a score of 300. If this team scored 300, that would be very significant. This team also is not tripling its score. They're all improving, but certainly the baseball team is improving by quite a bit more in terms of how this worked out there. Okay, so we're looking here at increases and decreases today, and we took a look real quick at which team improved the most. We would say the baseball team. Perhaps how you say they improved the most there. And again, this is just things you're noticing, things you're wondering. Let's move on to today's lesson today to talk about how this ties in with our previous learning and our new concepts of the day. It says a cereal box says that it now contains 20% more. Originally, it had 18.5 ounces of cereal. How much cereal does the box come with now? All right, this is a great little question, and there's a couple ways of thinking about this. All right, if we thought about how we did things before with our prior lessons, we might say something like, if I took the original and I have the whole original, okay, and I'm going to have 20% more, that means I'm adding to it 20% more of the original. So it's going to be an increase there. Okay, so I have my original amount plus 20% of the original. That would be my new product, the 20% more, right? New product. In this case, I do have a couple things I need to change around. One, I can leave my 1 times x like it is, but 20% needs to be written as a decimal. All right, to do that, I can take the decimal here and I'm going to move it over 2 hops that way to end up turning a 20% into 0.20 or just 0.2, and again that's still times x. Because this is a percentage increase, I then am going to take these values 1 and 0.2 and add them together to have 1.2, and then use the distributed part here and do 1.2 times x. All right, so this is my setup for how I would find out what is 20% more of the original. Now my original value was 18.5, so I can use that in place of x. And I end up with 1.2 times 18.5. Now 1.2 times 18.5 is going to be 22.2. So the new box of cereal is actually going to contain 22.2 ounces of cereal. Okay? And that's one way of solving that problem. Another way of doing it would be to look at it and say, well, I'm actually just wanting to do 20% of 18.5, and again this is going to be 0.20 times 18.5, which will give you, when you do 0.2 times that, that's going to give you an answer of 3.7. that is the additional 20%. 20% is a 3.7. So I need to add that back to my original amount, 18.5, and I have 12, decimal point comes down, and 12 and 2. So I have 22.2. Those answers are the same. I arrive at the same place. It's just a different approach to how you want to solve that problem. This is using what we learned in our previous lesson, and this one just takes it apart and says, let's just do 20% of it, and then add that back into it. The addition part here is really this, right? This 3.7, whoops, this 3.7, that 20% is this part right here. That's the 20%, and this 100%, 8.5 is the 1. So what we've really done is we've just broken it down a different way. These go together and those go together. In this example, I added the 1 and the 0.2 to make a 1.2 value. That was my addition here. Over here, I added, my addition part was there. All right, two different ways of looking at it. But we would overall call this is an example of what we call a percent increase. Okay, because we were increasing what we originally had by a certain percent. Let's look at the next one, which is going to be an example of what we would call a percent decrease. All right, so it says that the price of a shirt is $18.50. All right, so that's my original, right? Think back again. It's 1 times X. That's my original value there. But I have a coupon that lowers the price by 20%. That's going to be a decrease. I'm going to be subtracting by 0.20 times X. Right? That's my decrease value. So now using that distributive property again, I do 1 minus 0.20 times X. 1 minus 0.2 is 0.8 X, and that becomes my equation to find out what the price of the shirt's going to be after using the coupon. Now the original price was $18.50, so I can put that in the place for X. So I end up with 0.8 times 1850, and 0.8 times 1850 is going to be 14.80. So the price of a new shirt is going to be $14.80. Again, just using our decrease here of 1 and then 20% less than the original. To get that 0.8 value multiplied by the original price to get the new value there. Could I do it the other way? I sure could. I could do the 0.20, 20% of 1850, and 20% of 1850 again is 3.70. But now I need to take that amount and subtract it from the original. So 1850 minus 370. So that's my subtraction. Notice I subtract here. Again, these are my values I'm subtracting, just like I subtracted over there. And 1850 minus 370 is still going to be 1480. So you end up in the same place, just a different roadmap to get you where you want to be. 6.3, using tape diagrams. Match each situation to a diagram. Be prepared to explain your reasoning. Okay, here we go. Let's take a look at what I have here. First of all, I have one that has an A. I have an example of something at 100%, and this year we're going to be increasing by 25% because it's growing, it's getting larger. For B, we can see we have 100% and we are decreasing in our this year amount. We have less. In this case, it shows 25% less there. Now let's take a look at our situations. A says, compare with last year's strawberry harvest. This year's strawberry harvest is a 25% increase. So which one shows a 25% increase? We would say A is a 25% increase because it's growing by 25%. For B, this year's blueberry harvest is 75% of last year's. Well, it's not 100%, it's less than 100%. And in fact, if you did 100 minus 75, we would find that it's losing 25% of the amount it had before, which matches choice B. For C, we have compared with last year, this year's peach harvest decreased by 25%. That decrease again matches choice B. And this year's harvest is 125%. So what's that going to be? That's 100 plus the 25. You see this amount right here is 100. So 100% plus 25% is going to be 125% for what this year is going to be there. That would be choice A. All right, let's draw a diagram to represent the following situations. The number of ducks living at the pond increased by 40%. All right, so let's draw it like this. These are my original ducks, okay? My original ducks. Now, those original ducks then, that's whatever that value was, I don't know, is going to increase by 40%. Okay, that's my increase. So I started with the original, that matched there, and so my new value is going to be, right, the original plus the 40%. So overall, my new number of ducks is going to be 100% plus 40%, which is 140% of the original. All right, that's my original, and I'm increasing there. This is not a to scale kind of drawing or diagram. We're just drawing and saying that's 40%. Okay, let's look at number 3. If we were to say, and again just drawing a diagram here, if we were to say I had a number of mosquitoes, right? Here are my mosquitoes here. All right, and that's how many I had originally, was that amount there. And I'm decreasing by 80%. If I'm decreasing by 80%, I'm coming way down here, down to this point right there. That means this part is going away, 80%, and my new amount is here for what's remaining. Well, what's remaining is 100 minus 80, which would be 20%, is what's going to be left in my new value, new number of mosquitoes here, showing that decrease of 80%. So what could it mean to say there's a 100% decrease in a quantity? If an 80% decrease was doing 100 minus 80, if I had a 100% decrease, that's doing 100 minus 100, which would leave you with 0, nothing left. Give an example of a quantity where that makes sense. Let's say, for example, that yesterday I baked 100 cookies. Okay, I was really hungry. But today I wasn't feeling so well, so I made 100% less than I did yesterday. 100% less means I made no cookies. Right? Didn't do it at all. So just an example there. I shouldn't have had 100 cookies in one day. That was probably a bad idea. All right, agree or disagree? Do you agree or disagree with each statement? Explain your reasoning. Employee A gets a pay raise of 50%. Employee B gets a pay raise of 45%. So employee A gets a bigger raise. Do you agree or disagree? Agree or disagree? And again, this is a conversation for you to have with your classmates. And actually, as you talk about it, you could go with either one, depending upon some other factors you might want to consider, right? Do they both get paid the same amount to begin with? That's a big question. If they do, then we would agree. But if they get paid different amounts, we may not want to agree. So it really depends. For number 2, it says shirts are on sale for 20% off. If you buy 2 of them. As you pay, the cashier says 20% off each shirt means 40% off the total price. Well, I can tell you right now, you're getting a great deal, and the cashier's probably going to get fired because that's not quite how it works, is it? Right? Because what we're doing is we're doing 20% of shirt A, right? You're costing me 20% of shirt A, and 20% of shirt B. That becomes 0.20 times A plus 0.20 times B. And if we use our distributive idea again, the 0.20s actually go together this time because that's the common number, isn't it? They both have that on one side. And then what we're adding together is the A and the B value. So what happens here is you should be adding your shirt costs together and multiplying the sum of those shirts by the 20% value. If you do it times 40, you got yourself a little bit of an issue after the cashier. If you're the buyer, hey, you're doing great, what a great deal, but you might want to say something there. Okay, in summary, just kind of show you some pictures of what we did today, right? If Jada here and Andre, if Andre has 3/4 more time than Jada to get to school, that 3/4 becomes again 3, 1, 2, 3, and our original amount was in fourths, that becomes a 3/4 there. 3/4 is also going to be written as a decimal as 0.75, which as a percentage becomes 75%. So when I take that 75% here and add it to the 100, I end up with 175%. That's part of the idea of what we're doing here today. And again, this means in general terms, the terms percent increase and percent decrease describe an increase or decrease in a quantity as a percentage of the starting amount. So it's going up or down as a percentage of the starting amount, whatever you began with there. Okay, let's take a moment and look at today's homework. All right, for each diagram, decide if y is an increase or a decrease relative to x. So x is what we're starting with. That's our original amount there. And then determine the percent increase or decrease. Okay, well, looking here, x is a larger value than y. So we would definitely say that since we're losing something with y, this is going to be an example of a decrease problem. Now, how much is it decreasing by? Well, let's figure that out. We see that this is broken into fourths, right? So that's our denominator, is our fourths, and we're losing one of those fourths. So it's a decrease of 1/4. Now, we want to do that in terms of a percent, so we would do some division, and we would do 1 divided by 4, right? And if you use a calculator, you're going to come up with 0.25, and 0.25 as a percentage, we're going to move it over 2 places there, and we're going to say it's a 25% decrease is what we're looking at for letter A. For B, we can see that y is definitely growing, right? So this is going to be an increase. Now what is it increasing by? Look at my denominator first. That's the x value, 1, 2, 3, 4. That's what I started with. And then I added one additional one. So it's an increase of 1/4. So again, I know that that's the same as a 0.25, which is the same as a 25%. So we would call this a 25% increase for letter B. Number 2, draw diagrams to represent the following situation. The amount of flour that the bakery used this month was a 40% increase relative to last month. All right, so here's a diagram that shows how much flour was used last month, right? This is my last month. Now, last month was that much. Now this month, they had an increase of 40%. So here's my 40% increase. Okay, that's the increase. So that's my original plus the 40%. So my new amount this month is going to be 100 plus 40, which is 140%. Is how much flour they used this month compared to last month. For B, it says the amount of milk the bakery used this month was a 75% decrease. All right, so same idea. We're going to take our tape diagram, right? And we're going to say, well, here's the amount of milk they used last month, and they used all of it last month. But this month, there was a 75% decrease. That means I take this whole amount, and 75 I can chop it pretty easily, right? That's 50%, and that'd be in sections like this. So a 75% decrease means I'm dropping 25%. So I'm left with just this little chunk right here for this month, because this is going to be 75% is what I have right there. So that's 100 minus 75. So this month they only used 25% of it. It's the other way of thinking about it there. So it's a little bit different, right? So this month they're only using that much right there, 1/4 of the whole thing. Okay, number 3. Write each percent increase or decrease as a percentage of the initial amount. The first one is done for you. All right. So this year there was 40% more snow than last year. So the amount of snow this year is 140% of the amount of snow last year. Right? We're going to say 140 because it's 40% more than last year. So last year is the 100. We add the 100 to the 40, and we end up with 140%. And that's what we're going to do for the next ones too, except you have to write these out. Okay, so I'll kind of talk you through the number, but you're going to need to write down a little sentence there, all right? So for example, for B, it says this year there were 25% fewer sunny days than last year. In terms of the number for this response, we're going to do 25% fewer, which is 100 minus 25. So for this year, there are 75%. The number of sunny days is 75% what it was last year. Okay, so 75% of last year. We're looking at it as the original. Compared to last month, there was a 50% increase. That increase, I take the original plus the 50, I end up with 150% as my number. As a statement, I want to say that there was 150%, or there are 150% more houses sold this month compared from the previous month. So I'm doing it compared to the original. It's 150% of the original. The runner's time is 10% less, so that means it's going to be 90%, right? Because 100 minus 10 is 90. So it's 90% less time than last time, is the idea. Number 4. The graph shows the relationship between the diameter and circumference of a circle with the point 1 comma pi there. Find 3 more points that are on the line. All right, so to do this here, a couple ways you can think about it. You can make yourself a little chart if it helps you out, diameter and circumference. We know when the diameter was 1, our circumference was going to be pi, right? So we know that because why? Circumference equals pi times the diameter, using that equation from a previous lesson. So if my diameter was 2, I could say my circumference was 2 pi. If my diameter was 3, my circumference could be 3 pi. If it was 4, it would be 4 pi. Now, this value here, these values here are numeric, right? They're not in terms of pi, they're actual numbers. So maybe I multiply 2 times 3.14, I do 3 times 3.14. If I did that, I'd end up with 6.28 for this one, I end up with 9.42 for this one, and I could plot those out and say, well, here's 2, we're going to put a point right there, and that's going to be at 2 comma 6.28, and here's 3, we're going to put that right there, and that's going to be at 3 comma 9.42. Those are all going to work, and you do the same thing for 4 if you want to add that third point there. Okay, I'm just going to put 2 for now and move on. All right, Priya bought X grams of flour. Claire bought 3/8 more. So X and 3/8 more. So select all the equations that represent that. So we know we had, first of all, Priya bought the whole amount, and Claire bought 3/8 more. So we're going to add that 3/8 to what we started with here. So what we really have is we have 1 plus 3/8 times X. If we want to combine that together, we can have 8 times 1 is 8 plus 3 is 11. So I have 11/8 X. So here are 3 different ways of saying the same thing, correct? So looking at my options, 8 equals 3/8 X, or Y equals, right? This all becomes Y equals down there. That's not going to work because it doesn't include the original, so nope. For this one, we have Y equals 5/8 X. Again, doesn't add up the right way, that's subtracting. Nope. X plus 3/8, here's X plus 3/8, that matches that one right there. X minus 3/8, nope, because it's not less, it's more, not going to work. And Y equals 11/8, that one works right there, and we're set to go. Okay, hope that helps you out with today's lesson. Have a great day.